Hello, we are the team number 12 and this is our second delivery of the final project. In total, we have 7 different scientific hypotheses. The first one is that the operator affects phosphorus contamination. The second, the group affects phosphorus contamination. The third one is that the word shift affects phosphorus contamination. The fourth one is that the increment of portion of coke mineral versus iron affects phosphorus contamination. The fifth is that the temperature of arrival zone affects phosphorus contamination. The sixth is that the blast furnace purge time increments phosphorus contamination. And the seventh one is that the interaction between variables affects phosphorus contamination.
For this project, we generated 8 different statistical hypotheses. The first one is that the mean of phosphorus contamination of each operator is equal. Then, the mean of phosphorus contamination of each group is equal. The third one is that the mean of phosphorus contamination for each work shift is equal. Then, the mean of phosphorus contamination for each temperature to arrival of zone 1 is equal.
The mean of phosphorus contamination for each temperature to arrival zone 2 is equal.
The sixth one is that the mean of phosphorus contamination for each air feeding speed is equal. Then, the mean of phosphorus contamination for each proportion of coke mineral versus iron is equal. And last, the mean of phosphorus contamination of each purge time is equal. For each statistical hypothesis, we have the respective alternative hypothesis, that is that they are not equal.
Here we can see what each mean is and the null and alternative hypothesis. For point estimation, we choose 2 different types of regression. The first one is logistic regression. It can be used with all variables because they can be used as categorical or numerical, depending on what we want. In this case, for logistic regression, we will use variables as categorical. It can be used in variables like operator, group, and word shift. Also, we choose linear regression. We can use linear regression only with numerical variables like temperatures, airspeed, and purge time. Both regressions can give parameters that may help to build a function.
For interval estimation, we are planning to use either a confidence interval using SEED, and this can be used supposing that the data follows a normal distribution, and it can be used in all the variables. The other option is to use a confidence interval using T, and this is only if the population follows a t-distribution, and it can be used, for example, if we use a bootstrapping, for example, in a variable like operator. For hypothesis testing, we have 3 options. The first one is SEED, and it can be used with the variables like operator, and each variable will behave in a particular way. And with the SEED, we can see if the null hypothesis is going to be rejected or not for each case. The other option is Mann-Whitney, and we can use it if we assume that the data is not following a normal distribution. So it's a non-parametric. For example, the testing hypothesis of arrival in temperature at zone 1 mean. For the third one, we can use ANCOVA, and this can be used only if we use it in categorical variables in order to know if the independent variable affects the dependent variable. For example, we can use it in variables like operator to know if the mean affects phosphorus contamination.
For goodness of it, we choose chi-square. It can be used in non-parametric variables to observe the error between observed and expected value. If our value calculated is greater than the one in the table, we have a right goodness of fit. We can use it in all the hypotheses we have. The second method is R-squared. With a higher value of R, we will have a model that predicts better the values of the dependent variable. It can be used in all statistical hypotheses that we have.